Hello. Today I am going to explain you variable argument functions in C. In C programming, what we have learned since the early days, that the number of formal parameters that we specify at the time of declaring a function prototype, or maybe at the time of definition of a function, and when we invoke that function from some other function, the number of actual arguments must match with the number of formal parameters that we specify. Or in a layman's language, what we can say, that the number of formal parameters must match with the number of actual arguments that we specify at the time of invocation of the function. Now let me give you a typical scenario. I guess we have already learned how to write a simple function in C to find the sum of two numbers. Now if I give you a problem to solve, and let the problem statement be like, write a function to find the sum of n number of integers. Let me repeat the problem. Write a function in C to find the sum of n number of integers. So how will you approach this particular problem? I give you some constraints. You cannot pass an array as a function argument. Number two, you're not allowed to access any global variable or variables from the function. So how will you achieve this? At the same time, I won't allow you to perform any IO operation from within the function. So naturally you're going to ask me, since we can pass fixed number of parameters when we define a function, how do we write a function to perform the sum of variable number of integers? Let me just show you some small illustrations. Let us, for example, consider a function called sum. Let there be a prototype like this. Let this be number 1. Let the number 2 prototype be like this. We can write n number of prototypes. Is this a solution? How many functions you're going to actually define? One function for 2 integers, another function for 3 integers, next function for 4 integers. So you have to actually define n number of functions to find the sum of n number of integers. Now this is practically infeasible. So what's the way out? Let me ask you another simple question. Can you name a function or maybe a couple of functions where the number of parameters that we pass at the time of declaration, or the number of actual arguments that we pass when we call that function, is variable? Have you encountered any such function in C language? A function where the number of arguments we pass, it is a variable. It's not fixed number of arguments. I guess we can actually recollect probably the first function and the second function we learned when we started doing C programming. And I'm calling about 2 functions that we have already been using for years. And these functions are printf and scanf. What about printf and scanf? Let me just give you a particular example. In printf, we can use any number of arguments. Have you ever observed it? For example, we can write printf hello, where hello is a string data. Or we can write printf percentage d, where we have two format specifiers, comma a and b. In the first example, printf took one argument. In the second example, the printf took three arguments. Similarly, we can write printf percentage d, comma a, comma b, comma c. In the third case, printf took four arguments. So if we consider the function printf and if we observe it minutely, we find that the printf function accepts actually any number of arguments that we pass to it. I'll give you a small example of that. Let me just clear the board for you. What I was actually trying to explain, we have a printf hello. We have another printf we have a third printf So as you see, I have three printfs here, printf 1, printf 2, printf 3. How many arguments do we have here? 1. How many arguments do we have here? 3. How many arguments do we have here? 4. So this clearly explains us that to the printf function we can pass any number of arguments. Now today's objective is to write a user-defined function. I mean a function that can be defined by you, which can also take variable argument functions. So I'm going to show you a very small example where I'm going to demonstrate you a function called sum, and my function will be capable of finding sum of any number of integers. I'm going to explain you the concept of variable argument functions with the help of a simple example. So let us do the small task of writing a function that accepts variable number of arguments. So we define a function called sum n args. So my function named sum n args, the function which have the capacity to find sum of any number of integers. So how will the function prototype look like? Let me first write it down on the board, then I'm going to explain you why did I write that. I hope you have seen what I have written on the board. Did you see a function prototype that looks like this earlier? I guess no. What it means? See, in this case, I have one function parameter called n, which is quite a clear one and something which needs no explanation. It's a parameter of type integer. Now after comma, what do we have? We have 3 dots. See, there is no name of this parameter, it consists only 3 dots and we call it as ellipsis. Now ellipsis is a term that was coined when C was invented, and ellipsis refers to 3 dots, and these 3 dots signifies that this function, when it is defined, will be capable of accepting variable number of arguments. So ellipsis here tells to the user of this particular function, whoever is going to use this function, I mean to say the calling function, this function, when it will be called by another function, that function can pass any number of arguments to it where the first argument has to be compulsorily an integer here, which is being declared with the name n. This function prototype can be summarized in a sentence that follows like this. This function has a name called sum underscore enargs. The return type is integer and it consists of named arguments and unnamed arguments. Why we call it as named arguments? Because the first parameter has a name n and the second parameter, which is the ellipsis, has no name, so we call it as the unnamed argument, or rather unnamed arguments, because ellipsis refers to one or more arguments. Now we will define the body of this function. The first line that I am going to write is VA underscore list AP. Now what is this VA underscore list? Did you ever see this earlier? I guess no. Since you did not write variable argument functions earlier, so VA underscore list is something that is not known to you. Now this VA underscore list is present in a header that I am going to include now, which I did not include earlier. The name of the header is stdarg.h. The name of the header is stdarg.h. Let me just clear this part of the board so that it's visible to all of you. The name of the header is stdarg.h. If we expand this stdarg.h, we call it as standard argument.h. Now the standard argument.h contains this v underscore list. What is this? It's basically a type def. If you open the header file, you will see this is a type def, and ultimately the type def is what? Type def is a synonym of an existing type. So you will find that the existing type is of type pointer. I am not elaborating much right now about this v underscore list type def. Rather, my focus at this point in time is to show you how to write variable argument functions. Probably in my next session I am going to go more deep into the stdarg.h header file and explain you the components of that. Now, let me continue. I am going to have another variable called sum, which is initialized to 0. Now this sum variable will contain what? This sum variable will contain the sum of all the integers that we are going to compute. Now what is the significance of this? What is the significance of this parameter n? What is the meaning of the named argument? See, whenever we have a variable argument function, we pass any number of integers to it. So at the time of invocation of the function, how will the runtime know how many arguments we are actually passing to it? The named argument is an indicator about the number of unnamed arguments that follows. For example, if we call the function sum underscore n args with a named argument 4, then it means that we have 4 unnamed arguments. Or if we call sum underscore enargs with the named argument 3, then we have 3 unnamed arguments. So if I just show you an example, maybe pictorially, it looks like this. When I call this function, let me write it within comment line. When I call this function as sum underscore n args 4 2 3 2 1, it means that we have 4 unnamed arguments, and these 4 unnamed arguments are 2, 3, 2, 1. So if I want to find the sum of the variable argument function, what we have to do is that we have to start processing from here. And keep on adding the numbers one after another. So this actually is internally represented as a list. So what we can do is that we can actually assign a pointer to the beginning of the unnamed argument list and then retrieve one by one each number and keep on adding it. To do this, let me write the next line. We use VA underscore ARG, which is nothing but a macro. Again, present. I'm so sorry. We're going to use VA underscore start, which is a macro present in the header file stdarg.h. So VA underscore start AP comma n. What will it do? This will make the pointer AP point to the first unnamed argument after the named argument n, or what I wrote earlier, it will point to the unnamed argument 2 whenever we write VA underscore start AP comma n. Now once it is pointing to the first unnamed argument, then what we can do is that we can just loop through the list and keep on adding the numbers and store that in the variable sum. So we will write a loop. The loop looks like this: for in I equal to 0, how many times the loop will run? The loop will run n number of times, because n is the indicator about the number of unnamed arguments we have. I plus plus sum is equal to sum plus VA underscore ARG AP comma int. Now what is this VA underscore ARG? This is another macro which accepts two parameters. The first parameter is a pointer and the second parameter is a type of the unnamed argument. So what this VA underscore ARG will do? It will return the first unnamed argument after AP, add that to the sum, store it in the sum variable again, and automatically increment the pointer to the next unnamed argument. If you observe here, we are no way changing the pointer AP. The pointer will move automatically to the next unnamed argument after it returns the current argument. So what I can summarize? VA underscore ARG returns the current argument and moves the pointer to the next argument. So what will sum contain? The sum will contain the sum of all the unnamed arguments in the list. So what will be the next line? The next line will be VA underscore n AP. Now what is the use of this line VA underscore AP? This V underscore AP, you can see, is the line that releases all the resources that were required for the pointer AP. Since we were using the pointer AP in this particular function, we write V underscore AP to release all the resources that are currently being occupied by the pointer AP. As I said, the more details of the stdarg.h header file I will be discussing in my next session. Finally, the last line, once we have the result in the sum variable, what we will do? We will return the sum variable to the calling function. So here we find that 1, 2, 3, 4, 5, 6, 7. In 7 lines, we have written a function that's going to find the sum of n number of integers. So here sum underscore AR underscore NARG is the function which is going to actually do the work for me. So now finally what I'm going to show you is that how do you call this function. Let me clear the board. From the calling function, whichever it may be, what we can do is that we can write, for example, int result is equal to sum underscore in args 2, 3, 4. Int result 1 is equal to sum underscore in args 3, 4, 2, 1. Int result 2 sum underscore in args 2, 6, 7, 8, 9. So I've shown you 3 different examples of how we are invoking this sum underscore in args function. Look at the first one. Here, what is the value of the named argument? 2. How many unnamed arguments we have? 2. So as per my function definition, it's going to go through the unnamed argument list and will return the sum of the unnamed arguments. So what will be the value that will be returned by this function and will be stored in result? The answer will be nothing but 7. I hope you have understood this. What was the second one? 3. The named argument, unnamed arguments 4, 2, 1. So what it's going to return? 4 plus 2 plus 1, 7. The third one is an interesting one. See, the third one, what is the value of the named argument? 2. How many unnamed arguments we have? 4. So when we will call this function, based on the function invocation, we have only 2 unnamed arguments. So in this case, what will happen? Only the first 2 unnamed arguments sum will be computed. So the answer will be 13. The last 2 unnamed arguments will be ignored because they will not be processed. Let me show you a last statement to summarize today's session. Can you tell me what is the output of this? Printf percentage d a comma b comma c comma d. If you just type this code in your laptops, you will find that the output will be the value of a and the value of a and value of b. C and D will be ignored. C and D will be ignored. Why? The reason is same that I showed you earlier. In printf also, which is a variable argument function, in this case the format specifiers are the first named argument, which is nothing but a string literal, is an indicator about the number of unnamed arguments we have. Since here we have 2 format specifiers within the string literal, it will only consider the first 2 unnamed arguments. Rest of the unnamed arguments will be ignored. So we see that what we implemented and the way printf is implemented, it is quite similar. So I hope you have got a basic idea. About how variable argument functions work. Remember one thing. I hope if you revise, if you just revise what I taught you, and if you rewind this video, I said you one particular statement. I do not know whether you really observed or listened to it minutely. I said wherever it's a variable argument function, we have to have at least one unnamed argument. So what did I mean? it should look like this. Now, is it possible? Is it possible to have only the named argument and no unnamed argument at all? So I end this session with the simple quiz, with the simple question that I want all of you to probably try it out in your laptops and get back to me with the answer later. Thank you so much. Thanks for listening patiently to